Hello, we're Team 5. We'll start the final presentation on Burj Khalifa. We're gonna talk about role of team members, weekly plan, challenges, solutions about foundation, 3-day cycle process, measurement. This is role of team members. 허성원, 최현준 take a role about research and arrangement. 변상곤 takes a role about research and writing script. 이진우 takes a role about PPT planning and making. 장민지 takes a role about PPT designing and making, and 신용택 takes a role about presenter. This slide is why we choose building. How did they build a tall building in Dubai, a desert? How did Samsung C&T take charge of the construction of the world's tallest building? How does this building resist by so many forces? How do people on the high floor deal during fire? How does the technology of the time keep the tallest building ever? Dubai has grown rapidly due to oil strikes, but risk exists not only due to insufficient reserves, but also due to the development of its own industrial base. To solve these problems and enhance Dubai's status, they decided to build a skyscraper landmark. When Dubai declared that it would build an 800-meter building, Korean architects were skeptical. The Korean high-rise building firm also predicted that it would be impossible because there is no new technology. There were many difficulties in building the tallest building in the desert, as experts say. First of all, Dubai was close to the Northern Sea of the United Arab Emirates and had high salt underground water. Even Burj Khalifa was located closer to the sea than the interior. In addition, the problem was that the weak soil in the desert area was not stable for supporting the high-rise building. Also, the construction process of skyscraper requires a lot of manpower and up-to-date technical skill. This is related to the budget, and the construction period is proportional to the budget required. However, the budget was limited, so the project needed to be completed in a short period of time. There are problems that may occur during the construction process or after completion. The chronic disease of skyscrapers, the load management, and various disasters were expected and had to be prevented. From the next slide, we're going to talk about how we've solved these challenges from the bottom to the top. First of all, Adrian Smith of Somme, the master of skyscrapers, was the architect, and William F. Baker was the structural engineer. And the goal of the project was to build the tallest building in the world. These buildings will take worldwide attention, and the King of Dubai thought this building served as a milestone of industry. There is saying, a journey of 1,000 miles begins with a single step. Let's start with foundation. They had to come up with a foundation method that overcomes the weak ground of Dubai. The ground in Dubai was weak, about 50 meters below ground, and needed a way to overcome it. So, the foundation of the Burj Khalifa was applied with the raft pile foundation. The friction pile extends to about 24 meters below ground and transmits the load on the pile to the soil by friction, resulting in friction throughout the entire surface. The end-bearing pile, stretching to about 50 meters underground, acts like a pillar because it passes through weak soil and touches on a strong layer of soil. In other words, the entire surface of the pile works to transfer the forces to the soil. In other words, an bearing pile is placed in the center of the foundation to transfer the load to the strong soil layer, and surrounding friction pile prevents shaking through friction. Second, raft foundation. The raft foundation is continuous slab installed on the piles that supports the building and distributes its weight. Because it differs the weight of the building as a whole, it was used to build a weak ground, the Burj Khalifa, because it did not place a concentrated load on the individual points of the pile foundation. In other words, the pile and raft foundation are important factors that have made the world's tallest building safe despite the poor geological conditions in Dubai. To use methods, there are many benefits. 1. Piled raft foundation reduces the settlement. 2. Piled raft foundation is more economic foundations when compared to pure pile foundations. In the picture, the reinforcing bars that connect the piles with the raft maximize stability. In previous slide, there could be a risk of salty groundwater, so how did they solve it? Next, it was necessary to prevent the corrosion of pile caused by the penetration of high salt groundwater. First, we used the triming technique using polymer slurry to prevent groundwater intrusion. Let's see this video. This technique has drilled a borehole and then filled the hole with a higher density polymer slurry than the water to prevent groundwater intrusion. After that, the slurry caused by the density difference is displaced with concrete to act as a pile. They also use the waterproof membrane system to prevent corrosion of rivers. After completing the foundation by solving these problems, they started building on it. The main method used for Burj Khalifa is called 3-day cycle process. The reason why this construction method was selected is to reduce the construction period. Samsung C&T had experience first completed one floor on 4.5 days, so they could be main contractor. So, what is the 3-day process? The process of the 3-day process is rubber prefabrication on the first day and assembling and installing on the second day and pouring concrete on the last day to complete the floor. Let's see the technologies used in each step. First of all, prefabrication method was used in day 1. Rubber prefabrications were made on the ground and were divided into 3 podium zones for efficient measurement. Let's see about this. In phase 1, structural work is carried out using a crane for B zone. It acts as stockyard in A zone and C zone. At this time, C zone is in charge of the main stockyard. Later in phase 2, structural works are transferred from B zone to A zone. B and C acts as stockyard. Main stockyard also moved from C zone to B zone. In the last phase 3, the C zone rotates in charge of structural works. These prefabricated levers will be located inside the formwork by a crane on the second. Next on day 2, the process by which levels are inserted inside the formwork and movement of the formwork. The self-climbing formwork used in Burj Khalifa consists of modules, which can adapt to any type of layout and height of the building. Let's take a look at the video and see how it works. At first, release the rail arms and the rail climb step by step. And lock in next climbing anchor. Then formwork climb step. Finally, fix the bearing pin and lock the formwork. In fixed formwork, insert the prefabricated bar on the first day into the fixed form and finishing day 2 process. In the process of day 3, pour concrete into the mold, but as the height of the building went up, we needed a way to transport the concrete up to the high height. Let's find out how can pump the concrete. First of all, they needed a new pump system that could pump the concrete up to 600 meters. At the time, the power that was lacking in the best technology was solved through the development of a new pump by Putzmeister. As valve was used to resolve the enormous pressure of the concrete mixture. But they had to create a concrete mixture that was not only pump but also local climate. First of all, the problems that occur with normal concrete were as follows. Due to environmental influences, such as the temperature of the desert where the building is located, there are difficulties in the construction process. Early strength is also essential to raise one floor every 3 days, but it has to involve high hydration heat. General concrete is low in strength, and there is a risk of segregation if it is mixed in consideration of workability in order to push it too high. First of all, the concrete used in Burj Khalifa must be dried within 10 to 12 hours before the automatic climbing system can be operated. But early strength concrete generated hydration heat, and the hot weather in Dubai also played a part. This causes crack and is fatal to the building, so the temperature had to be managed. To solve this problem, they mixed ice pieces together in concrete mixing and controlled the hydration heat using fly ash. Also, concrete pouring was carried out at night to solve the problem of high temperature in hydration and region. Finally, in order to secure the workability of concrete, they increased the water to cement ratio and secured both workability and strength using spot plasticizer and silica fuel. They also adjusted the size of the aggregate that make up the concrete to control the workability. High-rise part concrete, which requires more workability, uses smaller aggregates. At the end of the third day, they went back to day 1 and cycled to complete one floor at a rapid rate. As the height of the building rises through the 3-day cycle, the problem to be solved is the load management of the building. Depending on the height of the building, the weight of the building as well as the strength of the wind increases the need to manage it. The characteristic of Burj Khalifa is that it solved load management through design. Some use the buttress core, a sectional design of the third building of Tall Palace in Korea. They adapted it to the local Burj Khalifa. Buttress core of Burj Khalifa consists of the center core and those columns on the outermost, and a corridor wall and a hammerhead wall that connects the flow of the load. At this time, corridor walls and hammerhead walls act as outriggers. Outrigger resists not only the axial forces but also lateral forces and protect Burj Khalifa from external hazards. Also, the axial force was resisted by the load redistribution of hammerhead wall and nose column. Also, the appearance of the buttress core played a major role in the resistance of the wind. The spiral shape allowed the wind to flow naturally, and, additionally, by setback it can resist strong vortex wind and prevent the lateral force. The completed buttress core method had excellent resistance to load, but damage caused by damage sustained on the exterior of the building should have been identified during construction or after completion. For this purpose, monitoring system was adapted and installed throughout the Burj Khalifa. Throughout this, they tried to secure the stability of the building. clear mirror installed outside the building detects damage, collect data, and periodically update information about the aging of building functions as well as whether the structure can perform its intended functions. From the clear mirror is sent to satellite and then collected from a GPS antenna installed on the roof. These processes have allowed us to predict damage to buildings or to find and repair damaged parts. Lastly, let's talk about the problems inside the building. Let's see how to evacuate a fire in the event of a fire due to a problem caused by height of the building. In the event of a fire, the installation of the refuge room was inevitable because residents on the high floor were not allowed to flee to the first floor. The refuge room is located on every 3 floors, so people can easily access it without much effort. Problem is the path to the refuge room in the event of the fire, which requires the smoke barrier to be blocked by a person in path. In the event of a fire to block the smoke, a special fan will operate within the escape stairs. Let's check through the video. First of all, when a fire is detected, a powerful fan is activated to prevent the spread of smoke in the evacuation steps and to secure the refugees' movement. Through this, we protected people by escaping to the refuge room. 10 years after its completion, Burj Khalifa still holds the record of the highest building. It served as a role model and milestone for Dubai's original goal. So we presented the background of Burj Khalifa, the foundation, the construction, the measurement process, and everything. This is our last slide. Thank you for listening.